How can you represent tabular data in programming? Watch this video to find out. Hello guys, welcome back to my YouTube channel. My name is Mike Mathuke E and this is my programming series. So today we're going to be looking at multidimensional arrays. So what are multidimensional arrays? It's basically, the simplest way I can explain it is an array within an array. That is a multidimensional array, or array within an array within an array, and so on and so forth. So we're just going to look at an example of this in comparison, starting with a 1D array, so that you can see how it actually looks like, then start leveling up to 3D arrays, right? So let's take a look at this. So here I have an example of a one-dimensional array, the kind of array that we're already used to, right? Where you have a linear representation of an entire list, and then you have your indexes 0, 1, up to 5. This is for an array with the size of 6, right? There are 6 elements, and then we start from index 0 all the way up to index 5, right? If you're looking at a two-dimensional array, then it will look something like this. So this is what a two-dimensional array would look like. So we already have an example of our original one-dimensional array here, but now we have them stacked up so that it looks more like a table, right? This is how you would represent tabular data. And then in this case, the indexes in blue will represent the first index. So there's an array at index 0 which has 6 elements, right? There's an array at index 1 which has another 6 elements, and so on and so forth. So this is kind of like how you'll represent a table, right? You have your rows and your columns, right? So each row contains a number of elements along the column, right? So that's how you'll represent tabular data in programming. So another thing we can look at is the 3D array, right? Three-dimensional array. That is basically something similar to the 2D array, where we have our rows and columns. But then when we reach the first, the index 0 row and the index 0 column, we have another array that is stretching out as a depth, right? It's heading out. That's what we've represented by the indexes of 0, 1, and 2 that are in yellow, right? So in this case, we'll call this 4 by 6 by 3 the three-dimensional array, right? It's kind of like a cube, right? So if I take, for example, here this Rubik's cube which I have here, so if we're looking at a 2D array, if we look at this right here, so we can see that a 2D array represented here in white would basically be, this is our height and this is our width, right? And then if we're looking at if this line is index 0, this is index 1, this is index 2, then our column would have this as index 0, this as index 1, and this as index 2, right? So if, for example, we wanted to access index 0 of the row and index 0 of the column, then we'll be looking at this first element right here. That's how we'll represent it. Now, if you're trying to look at it in 3D, where we have a three-dimensional array, then you'd add this aspect of, there's another, let's say this is 0, 1, and 2, right? Going towards me, 0, 1, and 2. So you'd have, if we're accessing the element at index 0, 0, like we had before in the 2D array, then what we would have is these 3 elements right here. The 3 together now form the index 0, 0, which means it's just another array that contains another 3 elements, right? So that's how you would represent it. That's how you can visualize it. But of course, it's always easier if you do it in code. So let's dive right in and look at it first of all in C++ and then in Python, so that we can see how that looks like. So in C++, so first of all, let's remind ourselves how a one-dimensional array would look like, the kind of array that we're used to. So how you would normally declare it is int array, you specify the size in C++, and then now you give the elements, so 1, 2, 3, and 4, for example, right? And then something that we need to note here, if you try and print out the value of this array, instead of getting the actual value, you'd actually get a pointer, right? You'd get a pointer. That pointer will basically represent the memory address of this array. You see, since we are declaring it statically in memory, so that basically means when we declare it this way, we'll have all this data put in one place in memory. That means if let's say if the element 1 is in, let's say, address 0, then element 2 will be at address 1, and so on and so forth, right? All the elements will be stored in continuous addresses within your memory, right? So in this case, if I try to print this array here, you'll see that what we get is this long hexadecimal value. This is basically the memory address of this array, and specifically the first element of the array, right? Since we can't store all the addresses at the same time, it just stores the memory address of the first element of the array, right? So that's all you get back. This is just R here in this case is just a pointer to the first element of the array, right? And then whenever we want to get the specific value at a specific index, of course, what you have to do is to do that, and the program will be able to know this person is trying to get the first element of the index, which is 1, right? So if this is a one-dimensional array, then what does a two-dimensional array look like, right? So I'll declare 1 here, and I'll call it a matrix. Kind of like how we have matrices. So let me use 3 by 3, right? So basically you're declaring that this is a matrix that will have 3 elements which contain arrays with 3 elements, right? So how you declare that is you declare your first array, so maybe 1, 2, 3, and then your second array, which is let's say 4, 5, and 6, and then your third array, which will be 7, 8, and 9, right? I hope this kind of makes sense. It's kind of like we're making this matrix where we have these elements. So you can see here we have an array here that contains 3 elements, another array here which contains 3 elements, and another array here which contains 3 elements. And then, of course, we've separated these 3 different arrays by commas so that they are also represented as elements of the first array. And now the question comes, how do we access these values in memory, right? So if I try to print the value of matrix first of all, so like we said before, what this returns is the pointer to the first element of the array, right? And if you want to access the first value of the array, of course we do it the same way that we've done with this, right? We go index at 0, right? If I print this value, what we'll see is that we have the same memory address being printed twice. So remember again, we are looking at pointers here. So whenever we have an array, what we get back is a pointer. So matrix is a pointer to the beginning of this whole array, and matrix at 0 will be the beginning of this first array that we have right here. So the reason why you're getting the same memory address is because the beginning of matrix is the same as the beginning of this first element of matrix, and that's why we're getting the same value. So if you want to get the first element of the first array, what we would do is we would now add another indexing position. So we'll say matrix at 0, at index 0, and also at index 0, so that we get from this we get the first array, that we have within the main array. And then from this, we get the first element of the first array. So if I print this, then we should expect to get 1. Why? Because we're looking at the first value of this element. If, for example, I wanted to get the second value of the element, all I have to do is to change this index, and what I'll get is the value 2, right? If I wanted to get, let's say, the first element of the second array, so we go to index 1 of the first, so that you can get the second array, and then index 0 for the first element of the second array. So if I run this, you can see that we get 4, just like we have it here. So that's how basically it works. That's how you declare your multidimensional arrays, and that's how you're able to access everything at a go, right? So that's basically how it works. If you wanted to do a 3-dimensional array, sometimes you might have a case where you want to do it. So I'll just do it as a simple example, and I'll call it cube. So we can have 3 by 3 by 3, right? And then in this case, I'll try to arrange this a bit differently so that you can look at it in a bit of a perspective, right? So I'll just copy this right here. So we have our main array, and then we have another array which will contain 3 elements like so. Then I can put a comma here and declare the second and the third element of this array, right? So you can see here we have this first array is represented by each of these lines, right? So we have those 3, and then the second 3 will be now these comma separated values 1, 2, and 3, and then the last 3 will represent now the values that we have within the array, like so. Okay, so that's how it basically works. And then to access this, it will be no different from how we are doing it here. I'll just change this to cube. So that we have, so first of all, I'll just like to access the first index, and then the deeper you go, the more indexes, of course, you add. So if I print this, let me just comment out this so that you're able to access only these are printed out. So if I run this, what you'll see is we have 3 memory addresses that have the same index, right? And then our last value here is 1, right? So again, the first element of each of these arrays will still contain the same memory address, since they are all starting at the same point in memory, right? That's why you'll find that these memory addresses match, these pointers match in value. So again, if I wanted to access, let's say the second array here, so I'll just do it like so. So now that means we are at this. So allow me to change this a bit so that we can have a difference in value. So I'll just add the 1s to this, so it's a bit different. And same for here, I'll just add 2s. So we have very different values that you can be able to differentiate, right? So in this case, we're looking at 1. So if you're going at 1, then this will be 0, and then this will be 1. So now it means we're looking at this. So what if, let's say, we want to access the value 11? Then we'll go to the first array, right? So that will be 1, then 0, right? And then next thing, if we want to access 11, then it will be index 0 here. So if I run this, then you'll see that you're able to get 11. So let's try another example. Let's say we are trying to get the value 18, for example, right? So in this case, this is index 0 of the first array, and then this is index 1, right? So we need to access index 1 first. Then next, now that we are in this section, we need to look at which of these contains the 18. So you can see is the third element. So that means it's index 2. So I can put index 2 here as well as here. Remember, we are trying to access 18. So if I want to access 18, now that we are at this point, we can try to look at which index it is at. So you can see it's at the second element, which means it's at index 1. So if I put 1 here, then if I run this, then we should be able to get our 18, right? So that's basically how multidimensional arrays work. So let's look at this in Python as well. So in Python, let's try and remind ourselves what we usually have when we have a normal array. So what we have is a list of integers in which you declare with 1, 2, and 3 like so, right? And then when we print our array, we get these values printed right here, right? So that's how we usually do our one-dimensional array, the ones that we're used to. So if you want to do a multi-dimensional array, right? So I'll call this matrix, and what it will be is a list that contains a list of integers. So this is basically how you would explain, or rather define, the two-dimensional array. It's a list that contains a list of integers, right? So if oops, sorry about that. So if I'm to write this in code, then what I'd put is an array within an array. So let's say 1, 2, and 3, and then comma separate each of those arrays so that we have, let's say, 4, 5, and 6, and then next we can have 7, 8, and 9. So that's how you represent a multidimensional array. So this is an array, this is an array, and this is an array as well. But then you can see we are comma separating them so that we have each of these arrays within another array, right? So that's how we call it a multidimensional array. In this case, it will be a 3 by 3, right? So there are 3 elements total, each of which contain 3 elements. So that's how we can think about it. So when we print this, it is fairly simple. We can print the entire array, and you can see it represents the same way that you've written it here. However, if we want to access, let's say we want to access our first array, right? So if we go back here to the one-dimensional array, if you wanted to access the first value, what we will do is we'll print array at 0, right? And that's how you'll be able to access index 1. So if I run this, you can see that we have our 1 printed here. So if I want to access the first value of this multidimensional array, I will do it the exact same way, right? I will just use index 0. But then what will that give us? It will give us the first array because it's an array within an array. So if I want to access the first element of the first array, right, here, what I would do is do matrix as 0, which returns our first array, and then now I do again index 0, which will give me the one that I'm expecting here. So let me just comment this out so that you can remain with visibility for only this multidimensional array. So for example, let's say I want to access the value 5, right? So what will I do? In this case, we can see that from the total of this, we can see that we have, this is our index 0, this is our index 1, and this is our index 2, right? So 5 is within the index 1. So what I'll do is go to index 1 here, right? And then I want to access the number 5. So within this array, we have index 0 here, index 1, and index 2. So 5 is on index 1. So if I want to access 5, then I have to do matrix at index 1, then at index 1 again. So if I run this, you can see that the first time that we print our matrix at 1, we have 4, 5, 6. And then the second time that we print, we have our 5, which we've gotten it directly. So if we try and take this further and do a 3-dimensional array, for example, let's call it cube. This will basically be a list of integers, right? So you can see we have basically it's three lists, a list within a list within a list, right? So how can I represent this in code? Well, in this case, I prefer to just separate them in line so that I can do it this way. So this is our two-dimensional, and then I can just copy down, right? So this is how you represent a three-dimensional array, right? So this is our index 1, our index 2, and then our index 3. And then within that, we have our index 1, our index 2, and then our index 3. And then next, we have now our index 1, index 2, and index 3, like so on. So in this case, let me just separate these numbers so that we have something different. I'll just add 1 to this line here, and then I'll add 2's to this line right here, so that we can be able to differentiate them whenever we're looking for a result, right? So if I want to access the cube, of course, we have our original print the cube, which will return exactly what you're seeing here. Next, we can do print cube at 0, which will give us this line right here. We comment that out. And then next, we can do cube at 0, then at 0, which should be able to give us 1, 2, 3. And then the last one, we do cube at 0, at 0, at 0. So you can see we're accessing these values 3 times, right? The same way as we call it the three-dimensional array, right? So if I try and run this, you can see our first value is just printed the exact same thing that we have here. So for this case, I'll just remove this so that we don't have to look at it so much. Next, we can see that we have our index 0, same as this line that we have right here. And then index 0, 0 will be this, 1, 2, 3, right? And then our index 0, 0, 0 will be the value 1, right? So that's how it comes out. So if we wanted to access, let's say, the value 16 right here. If you wanted to access the value 16, what will we do? So first of all, we'll look what index it is in the first array. So we'll see we have index 0, then index 1, then index 2. So 16 here is on index 1. So I'll change all this to 1. And then next, we'll look at in this array here that we have, which index position will it be at, right? So we have our index 0 here, we have our index 1 and our index 2, right? So definitely 16 is on index 1 here, so I'll just change this section to index 1. And then now we look at 16 itself, which is at index 0, 1, then 2. So here we'll put it at index 2. And so if I print this, we can see that our result comes out to, we have this as our index 0, then this as this here as our index 0. Sorry, this is our index 1, and then we have our index 1, 1 here. And then now we have our index 1, 1, 2, right? So that's basically how you would represent it within your code. So that's how multidimensional arrays work, and that's how you present them in code, and that's how you're able to access the values within each of those indexes. The other thing to note here is mostly you can use the 2D arrays. The applications of the 2D arrays are very diverse. You can use them in representing matrices. That's why I used matrix as my name here. You can use them to represent a table and row column, right? So basically X and Y. It is another way that you can represent it, or you can even use it to represent, let's say, points in 2D space, right? You can use it to represent points in 2D space. And then when it comes to a three-dimensional array, then now you can think about accessing values at the three-dimensional space, and so on and so forth. So that's how you can apply them, and that's how you represent them in code. I hope you've gotten to learn something today, and I hope to see you next time. Cheers.